All right. Good afternoon, everyone. What better way to round out the last afternoon of TDX than to talk about our favorite topic, closing the AI trust gap with the Einstein Trust Layer. But before I get started, I'm sure you've never seen this slide before, but just a nice reminder to make all of your purchasing decisions based on products and services that are currently available in market. And I also want to take a moment to say thank you. Thank you to our Trailblazers, our customers, all of our attendees, our partners. Our success wouldn't be possible without you, so thank you, and thank you for being here. I'll go ahead and introduce ourselves. So I'm Ellen Woodcock. I'm a director of product marketing here at Salesforce, and I'm here with my colleague Alex Klenschitz, who is an associate product manager here at Salesforce, and we're both focused on AI and specifically the Einstein Trust Layer. I don't need to belabor this point, right? You all have been probably talking about generative AI this entire conference. And if we think back to just a year ago, most companies were really apprehensive about generative AI. They didn't really know how they'd be able to work it into their business strategies. But today, companies can't deploy generative AI fast enough. However, most companies struggle to deploy it reliably, and they also struggle to do so while maintaining their customers' trust. So why is that exactly? What comprises the AI trust gap? Well, first and foremost, to state the obvious, data security and privacy, right? Anytime that you're using a generative AI feature, it has to interact with a large language model, which means that data gets sent from your org or your instance to a large language model and back. So that potentially compromises some of the security and privacy of your data. The second piece, which is actually a little bit less frequently talked about, but just as important, is that the accuracy and reliability and safety of generative AI. So what do I mean by that? Large language models are incredibly powerful, and they're getting better and better every single month. The improvements that we've made within the last year are really incredible. That being said, they're also kind of like a big black box. We can't really predict their behavior or understand exactly why they sometimes do the things that return the types of results that they do. And we certainly can't predict that they're going to reliably return the same types of results every single time, right? So if you're a user, just a consumer playing around with ChatGPT, and every now and then it hallucinates, it's not really a big deal, right? But if you're a company with a brand, that's a really big deal. If your consumers are interacting with a chatbot that's giving unreliable information or incorrect information, that's a liability to your brand. So all of these risks are preventing companies from effectively deploying generative AI and really getting value out of it. And at Salesforce, we're not new to AI. We've been thinking about AI for the last decade. We founded our AI research team 10 years ago now. And in 2016, we launched our first wave of predictive AI capabilities. So along this entire journey, we've been thinking a lot about trust. And when we launched our first wave of generative AI features this past summer, we did so with the Einstein Trust Layer. So what is the Einstein Trust Layer exactly? Well, it's not a product that you have to buy. It's a set of features, processes, and guardrails that are built directly into the Salesforce platform. And all of those things are really built to do three different things. First, to protect the privacy and security of your company and your customer data. Second, to improve the safety and accuracy of your AI results. And third, to promote the responsible use of AI across the entire Salesforce ecosystem. So that's within Salesforce, within your organizations, and then across the ecosystem of partners, AppExchange, et cetera. So the moment you've all been waiting for, we're going to talk a little bit about how all of this works. But before we dive into the specific features of the trust layer, I think it's important to take a step back and think about kind of the process that we're all familiar with, which is the general prompt, model, response workflow, right? So we're going to jump into a quick demo. Alex is going to hop over into Prompt Builder, which is an amazing new product that we launched just last week. It became generally available. And in Prompt Builder, you can build and customize prompt templates to scale generative AI reliably across your organization. So let's go ahead and jump right into Account Summary, which is a prompt template where we're basically using it to summarize an account object within Salesforce. So up at the top here, you can see in the prompt template workspace, the prompt contains a number of different, they'll see them as kind of color-coded fields. These are merge fields. So what these are doing are these are pulling in data points from Salesforce directly into the prompt. So the template has these merge fields in it so that when you look underneath, when we're going to generate the prompt, we will see that that gets populated with data about a specific account. So we'll go ahead and select the specific account. We'll select global media, and we'll run it against 3.5 turbo. It'll take just a minute to generate a response. But then when we look up above, we can see on the left-hand side the resolution. This is the prompt that has been hydrated with data from about the account. And then on the right, we see the response that would come back from the large language model. And you can see that in the response, we now have all of this really great information about that account, including contact name, contact information, potentially some competitive info. And all of this is great because it makes the response actually usable, but it's also containing sensitive data that we might not want to leave the Salesforce org and to go to the large language model. So we're going to talk a little bit about the guardrails that are happening behind the scenes that you can't see, which are preventing all of this data from leaving Salesforce. So I'll hand it over to Alex to talk through that.
Thanks, Ellen. Hello, everybody. My name is Alex Kalenchitz. I'm one of the product managers, and I work on Einstein Trust Layer. What I want to do with you today is to really walk through this diagram and really understand what technology powers each of these tiles. So let's dive in. Let's dive in more. Awesome. OK, we will start with what we call a prompt flow. This is the process that happens with the prompt before it even reaches the large language model. And we will start with what we call secure data retrieval. Secure data retrieval is technology that ensures that we respect the user access that you have configured in your Salesforce organization. What this means is that whenever the user generates a response, if they do not have access to certain data in your Salesforce org, we will not pull that data in, because we want to respect the data access rules that you have configured for your organization. Second is dynamic grounding. Dynamic grounding is really what powered the demo that Ellen just showed you, around making your prompt customizable and relevant to your business. And there's really a lot of different ways that we can use to do dynamic grounding. The first one, and the pretty simple one, is to use merge fields. That's what we have just seen in Prompt Builder. You can also do it in a more sophisticated way, like using grounding with flows, grounding with calling MuleSoft APIs, or even tapping into the data cloud data and really utilizing it by utilizing data graphs. Finally, you can use Copilot Search, which also is powered by retrieval augmented generation. Retrieval augmented generation uses all the knowledge base that you have in your Salesforce organization, vectorizes it in an embedded way, and then can efficiently search through the data to pull only the relevant information. The example of RAG would be, for example, pulling the relevant meeting notes, to only put the relevant meeting notes in your prompt so that we will not overcrowd the prompt with the grounding data. OK. Now that we have grounded our prompt, let's talk about one of the features of Trust Layer, which is data masking. When we do data masking, we basically substitute sensitive data with a placeholder. That placeholder still allows the LLM to see what the data was about, like a person's name would just be masked with a placeholder called name, so that the large language model will still understand that there was a name there, but it will not reveal what the actual name was. We can do data masking with multiple different ways. The first way is what we call pattern-based masking. Pattern-based masking utilizes a combination of regex-based matching and machine learning detection to detect sensitive data. We can detect things like credit cards, names, email addresses, and more. Furthermore, as you can see on the right side of the screen, you can configure what exactly gets masked in your org. If you do not want to mask email addresses, you can just turn it off. If you want to mask names of people, just turn it on, and it will apply to your entire org. In addition to that, a big benefit of pattern-based masking is that it works for any data type. Wherever the data came from when you were grounding with it, data masking will be applied to it. It can come from a flow, it can be a call transcript, whatever the text is, pattern-based matching will mask your data. In addition, this type of masking already speaks multiple languages. We support English, French, Italian, German, Spanish, and Japanese, and we continue adding more languages. Let's talk about another way to mask your data. That is called field-based masking. Field-based masking really utilizes the benefit of Trust Layer because it is built on top of the Salesforce ecosystem. That masking is based on the metadata in your Salesforce org. We will honor the existing sensitive data classification, compliance categorization, or even shield encryption if you already have it in your organization. As you can see on the right side of the screen, you can also configure what you want to be masked and what you do not want to be masked to fit the specific needs of your business. This type of masking supports Salesforce Core as well as the data cloud classification schemas. Okay. In addition to all of the masking that I have just explained to you, it will be even further configurable because you will be able to override the specific masking for a specific prompt or a specific model so that you can really tailor that technology to the needs of generative AI for your business. Okay, now that we have masked the prompt, let's talk about the last step before we send it to the large language model. That last step is prompt defense. As you know, whenever there's new technology coming around, there's malicious actors that are trying to break it. And that is really what we're trying to protect from when we're doing prompt defense. Salesforce does a 3D sort of approach to prompt defense. One of those dimensions are architectural design. Our generative AI platform is designed to withstand prompt attacks. We're limiting context windows and doing other number of architectural solutions to prevent prompt injections from being successful. In addition to that, we will be scanning for prompt injections in the prompts so that we will understand whether there is a chance that a given prompt may be malicious or not. If it is malicious, we will be blocking that prompt. And finally, at the very top here, we're utilizing what we call a system prompt wrapper, and I want to dig a bit deeper into that. A system prompt wrapper is basically a set of additional instructions to the large language model. Not only do they help with prompt defense, they also help with the accuracy of your overall response. As you can see at the very bottom here, we can tell the LLM that if it experiences an error, or if it is unsure of the validity of the response, it just has to say it doesn't know. These guardrails are not just something that we decide to use. We have a conversation design team that is constantly changing and testing these guardrails with an iterative process to make sure they are effective. Okay, well, that was a lot. We have finally prepared our prompt to be sent to the large language model, so let's do that. But you may ask, which large language model do we use? And the answer is, it's actually up to you which large language model you will choose. Salesforce has an open LLM ecosystem, and we have a series of Salesforce managed models, which today include OpenAI, Salesforce developed LLMs, Azure OpenAI, and more are coming. In addition to that, you can bring your own model. If you don't like any of ours, please feel free to bring your own instance of OpenAI, Azure OpenAI, and soon coming Amazon Bedrock, as well as Google Vertex AI. In addition to that, for Salesforce managed models, we have pioneered an additional security innovation. That innovation is called zero data retention. Zero data retention means that your data will not be used for model training or will not be used for model improvement by our partners. No data will also be retained outside of the Salesforce, and no human being will even be allowed to look at it. This way, we can really ensure that even if something happens and some of your data leaks outside of Salesforce, it will not be retained. Some people ask, well, zero data retention is great, but how can I verify that it exists? We can actually verify that it exists. On the account of Salesforce, when we manage OpenAI subscription and our agreement that we have with them, we can verify that zero data retention is active, and we have a cadence of checks when we check that zero data retention is there and your data is really secure, to make sure that all the technology is in place, and we have a same format and process with Azure OpenAI as well. Well, once the prompt is sent into the model, we will return back a response. What happens when we get back the response? The response starts by getting the sensitive data that was masked demasked. If you remember, I had a whole story about how we do data masking. Well, we need to demask those placeholders because we don't want your users to see the placeholders. That is the first step. Once we have demasked the data, we will also score it for toxicity. The Salesforce AI research team has developed a wonderful toxicity model, which is a Dilbert-based model, which is fine-tuned to score toxicity as a multi-label classifier. You can see on this screen, and we will see a live demo later that Ellen will show us, there's multiple categories of toxicity, like hate, profanity, toxicity, identity attack, and more, as well as the overall what we call a safety score. You want the safety score to be 1, and you want the category scores to be as close to 0 as possible, because you want your response to be very safe and not toxic whatsoever. This model was trained on publicly sourced data, and it also supports multiple languages, the same languages that our PII masking model supports, which is English, French, Italian, German, Spanish, and Japanese. Well, Finally, a lot of our customers ask us that they want to see what is happening with their generative AI. There are multiple reasons they may want to do that. The first one is that they may want to audit generative AI for compliance reasons. Another reason you may want to audit what is happening with generative AI is to improve your prompts. You may want to see how are the prompts doing. You may want to analyze the feedback that your users are giving to your prompts and potentially go back to Prompt Builder that we showed you earlier and modify it. That is where the audit trail comes in. Audit trail is a comprehensive log of all of your prompts, all responses, all the trust signals, and the feedback. And to really show us how audit trail works, I will pass it back to Ellen, and we will show you another live demo. Back to you, Ellen.
Awesome. Thank you, Alex. So we just talked about a bunch of different features and talked a little bit about how they work, but let's actually go into the audit trail and show you that they worked. So Alex is going to hop on over into the audit trail, and he's going to pull up a report. Let's first check to see that when we were preparing the prompt to be sent to the LLM, that we actually went and masked all of that sensitive data. So we're going to pull up our trust layer masking report, and you'll see on the left-hand side the prompt that was generated, and on the right-hand side you'll see the prompt that was actually sent to the LLM. So you'll see things like John Amos's name, he becomes person 0. His phone number is masked, his email is masked, all of this other sensitive information is masked. So that is the prompt that's sent to OpenAI. OK, so we know that OpenAI got the masked prompt, but let's see what happens on the back end, right? Or at the other end of that, when the response is sent back to Salesforce, right? Because we don't want a response that says person 0 instead of John Amos. So we'll pull up this second report that shows what happens with the response. And on the left-hand side, you can see the masked response text. So that is verbatim exactly what's returned from the large language model, right? But because it doesn't include that relevant data, not super useful. So we're going to show the response text, which has that data populated back into the response, which is what the end user sees. So if you're the end user, you don't even have to know that any of this is happening, right? It's all very seamless. So we've confirmed that data masking has happened, but let's also check for toxicity. So Alex talked a little bit about the toxicity scoring that's running in the background, and we're actually scoring a bunch of different categories. So things like hate, toxicity, identity. We're using a bunch of models to detect for these different types of categories, and we want them to all be as close to 0 as possible. And then we have a composite score, which is the full safety score, and we want that to be the closest to 1. So in this case, we can see that our composite safety score is 0.99. So, 0.999. Alex, I think that is a pretty safe response.
I believe so, too.
Great. Awesome. So we've confirmed that that's a safe response, and we've validated that all of those steps we just walked through were actually happening. We talked a little bit about, if we jump ahead to, we've talked a little bit about what's happening on the response layer, but there's also one important thing that's happening, which is responsible AI review. So before we even ship any of our products, each of our products goes through a comprehensive AI review in which we basically try to make sure that if there's an adversarial agent or someone trying to break the product, that they won't be able to do that. So we have a team that's dedicated to red teaming and testing, and for those of you who don't know what that is, it's basically just trying to break the product. So for example, you might try to get the large language model to return some kind of toxic content. You also might try to get the large language model to return sensitive user data, like passwords, to a user that's not supposed to see those. So we test for all of those things and make sure that we have the guardrails built into our system so that when we ship it to users, these types of security risks don't actually happen. So that's the Einstein Trust Layer. And to show you that we're really dedicated to delivering on the Einstein Trust Layer in every release. All of the generative AI features that the first wave that we shipped this past summer, they included all of the things we just talked about, like secure data retrieval, data masking, zero data retention. And then just last week, we released another new wave of innovations, which included things like dynamic grounding and prompt builder, which we showed you, access to audit crayon feedback data in Data Cloud, which we showed you as well, and then expanded configurability for data masking and things like that. And then further out, there's a lot more on the roadmap, so I can't wait for you to come to TDX next year when we'll tell you all of the other things that we launched. But we're working on things like field-based data masking, which Alex talked about, bias detection, data masking overrides. So if you're an admin, you can build in overrides to different types of data masking in the system, expanded observability, analytics, and alerting, and a lot more to come. So thank you. Really appreciate your time. Thank you for coming to this session. And make sure to give us feedback. We want to know what you thought about this session, and you might get a free coffee out of it. So go ahead and take the survey.